We are starting here inverse trigonometrical functions. Before starting, we will revisit the different trigonometrical functions, which are 6 in numbers. These are sine, second is cos, third is tan, fourth is cot, fifth is sec, and sixth is cosec. These are 6 trigonometrical functions. Domain of these functions are: sine has the domain a set of real numbers, or we can write it as minus infinity to infinity. Cos is also having the domain R, or we can write it as minus infinity to infinity. Tan has the domain R minus 2n plus 1 pi by 2, where n belongs to a set of integers. That means n can have a value from 0 to plus minus 1, plus minus 2, plus minus 3, and so on. Cot is having the domain R minus n pi, where n belongs to set of z for integers. Sec has the domain R minus. It is having the domain similar to tan, that is 2n plus 1 pi by 2, where n belongs to z. And cosec has the domain R minus n pi, n belongs to z. Corresponding ranges of these functions are: for sine, range is minus 1 to 1. That means value of sine will lie between the minus 1 to 1. Cos is having the same range, minus 1 to 1. Tan has the range R, that is set of real numbers. Cot is also having the set of real numbers. Similarly, the range of the sec is R minus 1 to 1, while range of cosec is also R minus 1 to 1. We can draw the graph of the different trigonometrical functions. Here it is sine. On x-axis it is x, and on y-axis we take the function value, that is sine x. Graph will be a rough diagram we are drawing here. The value maximum is 1 and minimum on negative side is minus 1. So minus 1 to 1 gives the range, while x extends from minus infinity to infinity, so it has the domain R. If we draw the cos x, on x-axis we take x and function is cos x. Cos x has the maximum value at 0, so the graph is like drawn here. It is again lying between 1 and minus 1, and on x value domain lie from minus infinity to infinity. If we draw the tan, on x-axis it is x, and tan x it is 0, pi by 2, pi. At 0 tan x is 0, and at pi by 2, that is at 90 degree, tan x is undefined, so graph is drawn here. This is the rough diagram, and on negative side it is minus pi by 2, and graph is similar to this. In the similar way, if we draw the cot x with respect to x on x-axis, so here it is having the graph at 0, it is undefined, so graph will be like drawn here. At pi by 2 the value is 0, and pi again it is undefined, and it repeats on both sides. Here it is minus pi by 2 and then pi, so we will have the value as drawn here. Next we will draw the sec x. On y-axis we take sec x and mark 2 points. One is 1, another is minus 1, and draw the parallel lines. On x-axis we mark the point 0, pi by 2, then pi, then 3 pi by 2, and so on. On negative side it is minus pi by 2, then minus pi, minus 3 pi by 2, and so on. And we draw the graph like here. At 0 sec x is 1, so it is increasing, and at pi by 2 it is undefined, and after pi by 2 on negative side it is drawn here. From at pi its value is minus 1, and at 3 pi by 2 again it becomes undefined. So in similar way its graph is repeating. We have this shape of the graph. This is the sec x. Similarly, we can draw the cosec x with x on x-axis, y that is equal to cosec x on y-axis. Again, we mark the point 1 and -1 on the y-axis and draw the parallel line with x-axis. And on x-axis, we mark the point 0, pi by 2, pi, 3 pi by 2, and so on. On negative side, it is minus pi by 2, minus pi, and minus 3 pi by 2, and so on. And to draw the graph, here we can see that at 0, it is undefined, and at pi by 2, cosec x is 1. So we can mark here, this is pi, so graph will be from infinity to 1, and then again infinity, and then on negative side, after pi, it will be repeating up to 2 pi and then again repeats. In similar way, on negative side, the graph will repeat. So this is the graph of cosec x.